Redis Deployment Introduction. Redis deployment means installing, configuring, securing, running, scaling, and monitoring Redis for application use. Software engineers use Redis deployment for caching, session storage, rate limiting, distributed locks, pub/sub, queues, counters, leaderboards, temporary data, Spring Boot cache, Node.js cache, microservices caching, cloud-native systems. A common learning topic is, how can backend and full-stack developers deploy Redis correctly? This guide explains Redis basics, local deployment, Docker deployment, Docker Compose deployment, Redis with Spring Boot, Redis persistence, Redis security, Redis replication, Redis Sentinel, Redis Cluster, Redis on Kubernetes, Redis monitoring, production checklist, common mistakes, interview questions, 30-day learning plan. Redis supports different operational modes, including standalone Redis, replication, Sentinel for high availability, and Redis Cluster for sharding and scaling. Redis Sentinel provides high availability for non-clustered Redis deployments, while Redis Cluster is designed for partitioning data across multiple Redis nodes. Simple definition: Redis is a fast in-memory data store, often used as a cache, session store, queue helper, and real-time data system. Simple deployment flow. Application: 00 Redis, database. Example: Spring Boot API, Redis cache, PostgreSQL. Simple idea. Redis equals fast temporary data layer. Database equals permanent source of truth. Why Redis deployment matters. Redis is easy to start, but production Redis needs careful planning. Without proper deployment, cache may disappear after restart. Redis may be exposed publicly. No password TLS. Memory may fill up. Eviction may remove important keys. No high availability. No monitoring. No backup strategy. Application may fail when Redis is down. With good deployment, check. Faster APIs, reduced database load, better scalability, safe configuration, persistence when needed, high availability, proper monitoring, predictable memory usage, better production reliability. Redis deployment architecture. Basic architecture: client, front-end, back-end API, Redis, database. Cloud native architecture: React, Angular, Vue, Spring Boot API, Redis cache, PostgreSQL, Kubernetes, Docker. High availability architecture. Application: Redis primary, replication, Redis replica, monitored by Redis Sentinel. Cluster architecture. Application: Redis cluster, primary 1 plus replica, primary 2 plus replica, primary 3 plus replica. Core Redis deployment concepts. Concept meaning: Redis server, running Redis instance, Redis client, application connecting to Redis, standalone Redis, single Redis instance, primary main Redis node accepting writes of primary Sentinel monitors Redis and handles failover, cluster sharded Redis deployment, persistence, saving Redis data to disk, RDB snapshot persistence, AOF, append-only file persistence, eviction, removing keys when memory is full, TTL, key expiration time, AOTH, password-based authentication, TLS, encrypted network. Communication. Step 1. Local Redis deployment. Install Redis locally if you want quick development. On Mac OS with Homebrew. Brew install Redis. Start Redis. Brew services. Start Redis. Check Redis. Redis CLI. Ping. Expected. Pong. Stop Redis. Brew services. Stop Redis. Use local Redis for tech, learning, local Spring Boot development, simple cache testing, CLI practice. Avoid local-only setup for production, team shared environment, high availability testing. Step 2. Redis CLI basics. Connect. Redis CLI. Set key. Set user 1, John. Get key. Get user 1. Delete key. Del user 1. Set with TTL. Set product 1001. Keyboard EX60. Check TTL. TTL product 1001. List keys. Keys. Warning. Avoid keys capital case in production. Use scan instead. Safer scan. Scan 0. Match product count 100. Step 3. Docker Redis deployment. Run Redis using Docker. Docker run -name Redis dev -p 6379 d Redis check container. Docker ps. Test. Docker exec it Redis dev Redis CLI ping expected. Pong stop. Docker stop Redis dev. Remove Docker rm Redis dev. Use Docker Redis 4. Local development. Repeatable environment. Integration testing. Quick experiments. Step 4. Redis with Docker volume. Without volume. Container removed. Redis data may be lost. With volume. Docker volume create Redis data. Run. Docker run /name Redis dev p 6379 to 6379 v Redis data to data d Redis latest Redis server append only yes. Y. Volume stores Redis persistence files outside the container. Useful for key local persistence, checking restart behavior, check avoiding accidental data loss. Step 5. Docker Compose Redis deployment. Docker compose.yml. Services. Redis. Image. Redis.latest. Container name. Redis dev. Ports. 6379. Command. Redis server. -append only yes. Volumes. Redis data. /data. Volumes. Redis data. Start. Docker Compose up. D. Check. Docker Compose ps. Test. Docker exec -it Redis dev Redis CLI ping. Stop. Docker Compose down. Stop and remove volume. Docker Compose down -v. Step 6. Redis Stack deployment. Redis Stack includes Redis plus additional capabilities and Redis Insight for local visualization. Docker example. Docker run d-name Redis Stack -p 6379 to 6379 -p 8001 to 8001 Redis Stack latest. Use Redis Stack 4. Shuck local development. Shuck Redis Insight UI. Shuck learning Redis data structures. Shuck visualizing keys. For production-style server-only deployment, Redis documentation separates Redis Stack images that include Redis Insight from server-only images. Step 7. Redis with password. For development with password, Docker run -name Redis secure p 6379.6379 d Redis.latest Redis server -require pass my strong password. Connect. Redis CLI a my strong password. Ping. Ping. Better production approach. Use strong password from environment/secret manager. Do not hardcode password in Git. Step 8. Docker Compose with password services. Redis. Image, Redis latest. Container name, Redis secure. Ports, 6379. Command, Redis server, #require pass, $Redis password. Append only yes. Volumes, Redis data, /data. Volumes, Redis data. .env. Redis password equals change this password. Important. Do not commit real production.env secrets. Step 9. Redis configuration file. Create redis.conf. Port 6379. Bind 0.0.0.0. Protected mode yes. Require pass. Change this password. Append only yes. Max memory 512 MB. Max memory policy all keys LRU. Docker Compose. Services. Redis image, Redis latest. Container name, Redis configured. Ports 6379. Volumes. Redis conf /usr local etc Redis conf. Redis data command. Redis server /usr local etc Redis conf. Volumes. Redis data. Use config file when configuration is growing. You need repeatability. Multiple environments exist. Production setup is required. Step 10. Redis persistence. Redis is in memory, but it can persist data to disk. Main persistence options. Option, meaning RDB snapshot file at intervals, AOF, append every write operation, RDB plus AOF, hybrid durability approach, no persistence, pure cache mode. Redis documentation describes RDB snapshots and AOF append-only files as Redis persistence options. Step 11. RDB persistence. RDB means Redis saves snapshots at intervals. Example: save 901, save 310, save 60, 10,000. Meaning, save snapshot after 900 seconds if one key changed, after 300 seconds if 10 keys changed, after 60 seconds if 10,000 keys changed. Benefits: compact file, faster restart than huge AOF sometimes. Good for backups. Risk: recent writes can be lost between snapshots. Use RDB for cache with backup. Read heavy data. Acceptable small data loss. Step 12. AOF persistence. AOF means Redis logs every write command to a file. Config. Append only, yes. Append fsync, every sec. Common AOF sync options. Option meaning always safest. Slowest every sec, good balance. No fastest, less safe. Most common practical choice. Append fsync, every sec. Benefits: column, better durability than snapshots. Less data loss risk. Drawbacks: X, larger files. X, write overhead. X, needs rewrite, compaction. Step 13. No persistence mode. For pure cache. Save, append, only, no. Use when. Check. Redis only stores temporary cache. Database is source of truth. Data loss is acceptable. Fast restart with empty cache is okay. Example: product cache can be rebuilt from PostgreSQL. Avoid no persistence for sessions if users must stay logged in. Queues needing durability. Rate limit state, if important. Business critical, temporary state. Step 14. Redis memory configuration. Set memory limit. Max memory, 512 MB. Set eviction policy. Max memory policy. All keys LRU. Common eviction policies. Policy meaning no eviction. Return error when memory full, all keys LRU. Evict least recently used key. Volatile LRU, evict LRU keys with TTL. All keys LFU. Evict least frequently used key. Volatile TTL. Evict keys with nearest expiry. For general cache, all keys LRU. Or all keys LFU. For strict data safety. No eviction. Step 15. Redis security basics. Production Redis security checklist. Call, do not expose Redis publicly. Call, require authentication. Call, use strong password. Call, use TLS when needed. Call, bind to private network. Call, restrict firewall security groups. Call, use Kubernetes secrets or Cloud Secret Manager. Call, avoid dangerous commands in production. Call, monitor failed authentication. Call, do not log secrets. Bad. Redis open on public internet. No password. Port 6379 exposed to everyone. Better. Redis private network only. Auth enabled, TLS enabled, if required. Firewall restricted. Secrets managed securely. Step 16. Redis network security. Local development. Ports 6379, 6379. Production, Docker, Kubernetes. Avoid exposing Redis directly to the public internet. Only backend services should access Redis. Better architecture. Internet, API gateway, backend service, private network Redis. Not. Dot. Internet, Redis, step 17. Redis with Spring Boot. Maven dependency. Dependency, group ID, org.springframework.boot, group ID, artifact ID, Spring Boot starter data Redis, artifact ID, application config. Spring data Redis, host, localhost, port 6379, password, $, Redis password. Service example, @service, public class, product cache service. Private, final, string Redis template, public product cache service. String Redis template. This Redis template equals Redis template. Public, void, cache product name, long product ID, string name. Redis template.ops for value, .set, product plus product ID plus name. Name, duration of minutes 10. Public string, get product name long product ID, return Redis template.ops for value.get, product.plus product ID plus name. Step 18. Spring Boot cache with Redis. Enable caching. Configuration. Enable caching. Public class, cache config. Service. @service public class, product service. Private final product repository. Public product service, product repository. This product repository equals product repository. @cacheable, value equals products, key equals product ID. Public product response get product, long product ID. Product equals product repository dot find by ID, or else throw 2 new runtime exception, product not found. Return new product response, product get ID, product get name, product get price. @cache evict, value equals products, key equals hash product ID. Public void delete product cache, long product ID. Flow. First request means database. Next request means Redis cache. Step 19. Redis for session storage. Redis is commonly used for shared sessions. Architecture. Load balancer. Spring Boot instance 1. Spring Boot instance 2. Spring Boot instance 3. Redis session store. Why? Any application instance can read same session. Use for Carolyn, horizontally scaled web apps, login sessions, short-lived user state. Be careful. Configure TTL, secure Redis, do not store unnecessary sensitive data. Plan for Redis failure. Step 20. Redis replication. Replication means Redis replica copies data from primary. Architecture. Redis primary, Redis replica 1, Redis replica 2. Benefits. Read scaling, high availability foundation, failover support with Sentinel, backup reads. Redis replication allows replica instances to be copies of the primary and automatically reconnect when the link breaks. Basic config on replica. Replica of Redis primary 6379 master off your password. Step 21. Redis Sentinel. Redis Sentinel provides click monitoring, click automatic failover, click notification, primary discovery for clients. Architecture. Sentinel 1, Sentinel 2, Sentinel 3. Monitor Redis primary. Replicate Redis replica 1, Redis replica 2. If primary fails, Sentinel detects failure, promotes replica. Clients connect to new primary. Redis Sentinel is intended for high availability when not using Redis Cluster. Step 22. Redis Sentinel config example. Sentinel.conf. Port 26379. Sentinel monitor mymaster Redis primary 6379 2. Sentinel off pass mymaster your password. Sentinel down after milliseconds mymaster 5000. Sentinel failover timeout mymaster 10,000. Sentinel parallel syncs mymaster 1. Meaning. mymaster equals Redis primary name. 2 equals quorum. Sentinel needs agreement before failover. Use Sentinel when check. Single primary with replicas is enough. Check. High availability is needed. Check. Automatic failover is needed. Check. Data fits one Redis primary. Step 23. Redis Cluster. Redis Cluster is used for sharding data across multiple Redis primary nodes. Architecture. Redis Cluster. Primary 1 plus replica 1. Primary 2 plus replica 2. Primary 3 plus replica 3. Use Redis Cluster when data is too large for one node. Throughput needs multiple primaries. Horizontal scaling is required. Sharding is needed. Redis Cluster distributes keys across hash slots and supports partitioning across multiple Redis nodes. Step 24. Sentinel versus Cluster. Feature Sentinel Cluster. Main purpose: high availability, sharding plus scaling. Data split? No. Yes. Multiple primaries? No. One active primary? Yes. Auto failover? Yes. Best for HA for one dataset, large high-throughput dataset. Complexity, medium. Simple rule. Use Sentinel when one Redis primary is enough, but you need failover. Use Cluster when you need to split data across multiple primaries. Step 25. Redis on Kubernetes. Kubernetes deployment options. Check. Standalone Redis deployment. Check. Redis stateful set. Check. Redis with persistent volume claim. Check. Redis Sentinel architecture. Check. Redis cluster architecture. Redis operator Helm chart. Managed Redis outside Kubernetes. Simple standalone Kubernetes architecture. Spring Boot pod. Redis service. Redis pod. Persistent volume claim. For production, many teams prefer managed Redis service or operator Helm managed Redis HA deployment because stateful systems are harder to operate. Step 26. Simple Kubernetes Redis deployment. Redis deployment.yaml. API version apps/v1. Kind deployment. Metadata. Name Redis. Spec. Replicas 1. Selector. Match labels. App Redis. Template. Metadata. Labels. App Redis. Spec. Containers. Name Redis. Latest. Ports. Container port 6379. Command. Redis server. -ep end only. Service. API version v1. Kind service. Metadata. Name Redis. Spec selector. App Redis. Ports 6379. Target port 6379. Apply. kubectl apply f redis deployment.yaml. kubectl apply f redis service.yaml. Spring Boot config inside Kubernetes. Spring data Redis. Host Redis port 6379. Step 27. Kubernetes Redis with PVC. Use PVC for persistence. API version v1. Kind persistent volume claim. Metadata. Name Redis data. Spec. Access modes. Read write once. Resources. Requests. Storage. 5GI. Mount volume. Volume mounts. Name Redis data. Mount path /data. Volumes. Name Redis data. Persistent volume claim. Claim name Redis data. Use PVC when persistence is required. AOF RDB files must survive pod restart. Redis stores sessions or important temporary data. For pure cache, PVC may be optional. Step 28. Kubernetes Redis secret. Secret. API version v1. Kind secret metadata. Name Redis secret. Type opaque string data. Redis password. Change this password. Use in deployment. Env. Name Redis password value from secret key ref. Name Redis secret. Key Redis password. Command dash Redis server dash require pass dash Redis password. Important. Use Kubernetes secrets carefully. Restrict access using RBAC. Step 29. Redis health check. Docker health check. Health check. Test. CMD Redis CLI ping. Interval 10 seconds. Timeout 5 seconds. Retries 5. With password. Health check. Test. Redis CLI, $, ping, interval 10 seconds, timeout 5 seconds. Kubernetes readiness idea, readiness probe, TCP socket, port 6379, initial delay seconds 5, period seconds 10. Use health checks 4. Check container readiness, check restart detection. Check deployment validation, check monitoring. Step 30. Redis monitoring. Monitor Redis metrics. Memory usage, CPU usage, connected clients, commands per second, cache hit rate, cache miss rate, evicted keys, expired keys, blocked clients, replication lag, persistence errors, slow commands, rejected connections. Useful Redis command. Info. Check memory. Info memory. Check stats. Info stats. Check replication. Info replication. Check slow logs. Slow log get 10. Step 31. Redis cache hit rate. Important metric. Cache hit rate equals hits over hits plus misses. Redis stats. Key space hits, key space misses. Example. Key space hits equals 900. Key space misses equals 100. Hit rate equals 900 over 1000 equals 90%. Interpretation. Hit rate meaning 90% plus, very good for many caches. 70 to 90% often acceptable. Below 50%, cache may not be useful. Very low, bad key design or TTL too short. Step 32. Redis slow log. Slow log shows commands taking too long. Command. Slow log get 10. Common slow causes. Huge keys. Expensive commands. Large keys. Large sorted sets. Bad Lua scripts. Network latency. CPU saturation. Avoid in production. Keys. Prefer. Scan 0 match pattern. Count 100. Step 33. Redis backup. Backup depends on persistence. 4. RDB. Backup dump.rdb. For AOF. Backup append-only.aof or append-only directory files. Production backup checklist. Cross, no, persistence mode. Cross, backup Redis data directory. Cross, test restore process. Cross, secure backup files. Cross, define RPO RTO. Cross, monitor persistence failures. For pure cache. Backup may not be necessary. Rebuild cache from database. For session queue-like usage. Backup and HA are more important. Step 34. Redis disaster recovery. Disaster recovery asks, if Redis fails, what happens? Possible answers. Pure cache application falls back to database. Cache warms again. Session store users may be logged out if Redis data is lost. Need persistence, replication, HA. Rate limiter limits may reset. Usually acceptable depending on system. Queue job data. Data loss may be serious. Need persistence and careful design. Step 35. Redis deployment decision matrix. Use case, recommended deployment. Local learning, Docker Redis, local UI, Redis Insight. Redis Stack. Simple dev app, Docker Compose, small production cache. Managed Redis or single Redis with backups. Session store, Redis with persistence plus HA. High availability Redis Sentinel. Redis HA, large data, high throughput Redis Cluster Kubernetes production. Managed Redis or operator Helm. HA critical business data. Reconsider Redis only design. Step 36. Redis with Node.js. Install. npm install Redis. Client. Import create client from Redis. Const client equals create client. URL redis.localhost 6379. Client.on error console.error Redis error. Await client.connect. Await client.set message hello Redis ex60. Const value equals await client get message. Console.log. Use Node.js Redis for cache, sessions, rate limiting, job metadata, pub, sub. Step 37. Redis with Docker Compose plus Spring Boot plus PostgreSQL services. App build. Ports 8080 to 8080. Environment: Spring Data Redis host, Redis. Spring Data Redis port 6379. Spring Data Source URL: JDBC PostgreSQL, Postgres 523. App depends on Redis. Image: redis.latest. Command: Redis server -append only yes. Volumes: Redis data. Postgres. Image: Postgres 16. Environment: PostgresDB app. Postgres user app. Postgres password app. Volumes: Postgres data var-lib PostgreSQL data. Volumes: Redis data. Postgres data. Architecture: Spring Boot app. Redis. PostgreSQL. Step 38. Production Redis checklist. Before production, confirm. 1. Is Redis private network only? 2. Is authentication enabled? 3. Is TLS needed? 4. Is max memory configured? 5. Is eviction policy configured? 6. Is persistence needed? 7. Is data volume mounted? 8. Is backup configured? Is monitoring enabled? Is high availability required? Is failover tested? Are application timeouts configured? Are Redis errors handled gracefully? Are secrets stored securely? 15. Is capacity sized correctly? Step 39. Common deployment modes. Mode 1. Standalone Redis application. Single Redis. Good for. Check. Local development. Simple cache. Non-critical workloads. Risk. X. Single point of failure. Mode 2. Redis primary plus replica. Application -Redis primary -Redis replica. Good for. Read scaling. Backup replica. Basic redundancy. Risk. X. Failover may need automation. Mode 3. Redis Sentinel application. Redis Sentinel discovers primary. Redis primary plus replicas. Good for. Check. Automatic failover. Check. High availability without sharding. Mode 4. Redis Cluster application. Multiple Redis primaries. Sharded data. Good for. Check. Large data. Check. High throughput. Horizontal scaling. Mode 5. Managed Redis. Examples: AWS Elasticache. AWS Cache for Redis. AWS Google Memory Store. AWS. Good for. Production. Backups. Patching. Monitoring. Failover. Less operations burden. Trade-off. Cost. Provider lock-in. Less low-level control. Step 40. Real-world deployment example project. Redis Cache for product catalog. Architecture. React frontend. Spring Boot product API. Redis Cache. PostgreSQL. Flow. Get API. Products 1001. Check Redis key product 1001. Hit return product. Miss read PostgreSQL. Store product in Redis for 10 minutes. Return product. Update flow. Put API products 1001. Update PostgreSQL. Delete Redis key product 1001. Next read reloads cache. Redis key product 1001. TTL. 10 minutes. Eviction policy. All keys LRU. Common beginner mistakes. 1. Exposing Redis publicly. Bad. Redis port 6379 open to internet. Better. Redis only accessible from backend private network. 2. No password. Bad. Redis has no authentication. Better. Use off ACL password from secret manager. 3. No max memory. Bad. Redis memory grows until server crashes. Better. Max memory 512 megabytes. Max memory policy all keys -LRU 4. Wrong eviction policy. Bad. Using no eviction for cache under high traffic. Problem. Writes fail when memory full. Better. Use eviction policy based on use case. 5. Thinking Redis is always durable. Bad assumption. Redis always keeps data after restart. Reality. Persistence depends on RDB AOF configuration and volume setup. 6. No monitoring. Bad. Redis is deployed, but nobody watches memory, hit rate, evictions, or latency. Better. Monitor Redis, like any production dependency. 7. Using Redis as main database accidentally. Bad. Store important order payment data only in Redis. Better. Use PostgreSQL, MySQL, MongoDB as source of truth. Use Redis for fast temporary access unless specifically designed otherwise. 8. No timeout in application. Bad. App waits too long when Redis is down. Better. Set Redis connection and command timeouts. Fall back to database for cache use cases. Best practices. Use Docker Compose for local development. Use password authentication. Keep Redis private. Configure max memory. Choose eviction policy carefully. Use TTL for cache keys. Enable persistence when data matters. Use volumes for persistence. Monitor memory, latency, evictions, and hit rate. Use Sentinel or Managed Redis for HA. Use cluster when sharding is required. Avoid dangerous commands in production. Use scan instead of keys. Handle Redis failures in application code. Use secrets for passwords. Test restart and failover scenarios. Document Redis use case clearly. Redis deployment interview questions. 1. What is Redis? Redis is an in-memory data store commonly used for caching, sessions, rate limiting, pub/sub, queues, and real-time data. 2. Why deploy Redis? To reduce latency, reduce database load, improve scalability, and store fast temporary data. 3. What is standalone Redis? A single Redis instance. Good for local development and simple non-critical workloads. 4. What is Redis persistence? Persistence means saving Redis data to disk using RDB snapshots, AOF logs, or both. 5. What is RDB? RDB is Redis snapshot persistence. It saves point-in-time snapshots to disk. 6. What is AOF? AOF means append-only file. It logs write operations so Redis can rebuild data after restart. 7. What is Redis replication? Replication copies data from a primary Redis node to replica nodes. 8. What is Redis Sentinel? Redis Sentinel provides monitoring and automatic failover for non-clustered Redis deployments. 9. What is Redis Cluster? Redis Cluster shards data across multiple Redis primary nodes for scaling and availability. 10. Sentinel versus Cluster. Sentinel gives high availability for one primary dataset. Cluster gives sharding and scaling across multiple primaries. 11. What is max memory? Max memory limits how much memory Redis can use. 12. What is eviction policy? Eviction policy defines which keys Redis removes when memory is full. 13. Why should Redis not be public? Redis often stores sensitive or operational data, and public exposure creates serious security risk. 14. How do you monitor Redis? Monitor memory, CPU, connected clients, command latency, hit rate, misses, evicted keys, expired keys, replication lag, and slow logs. 15. What happens if Redis fails? For cache use cases, application can fall back to database. For sessions or important temporary data, use persistence and high availability. Redis deployment roadmap, beginner level. Learn. Seek Redis basics. Seek Redis CLI. Seek set-get-del. Seek TTL, Docker Redis, Docker Compose Redis. Build. Run Redis locally and connect from Spring Boot. Intermediate level. Learn. Check persistence, RDB, AOF, max memory, eviction policies, password security, Spring Cache with Redis. Build. Product API with Redis Cache and TTL, advanced level. Learn. Replication, Sentinel, Redis Cluster, Kubernetes deployment, monitoring, backup, restore, failover testing, build. Highly available Redis deployment for cloud-native app. 30-day learning plan week 1, Redis local and Docker. Learn. Check. Redis CLI. Check. Docker Redis. Check. Docker Compose. Check. Set get. Check. TTL. Basic config. Practice. Deploy Redis locally and test with Redis CLI. Week 2, Redis with application. Learn. Spring Boot Redis. Redis Complete. Spring Cache. Cache keys. TTL. Cache eviction. Practice. Build Spring Boot product API with Redis Cache. Week 3, Production Basics. Learn. CAS, password, private networking, persistence, max memory, eviction policy, monitoring. Practice. Deploy Redis with password, volume, AOF, and memory limit. Week 4, high availability. Learn. X, replication. X, Sentinel. X, cluster. Kubernetes. X, backup. X, failover. Practice. Design Redis HA architecture for microservices. Real-world project. Redis deployment for Spring Boot e-commerce app. Architecture. React frontend dash Spring Boot API dash Redis dash PostgreSQL. Features. Redis Docker Compose deployment. Password configuration. Persistent volume. AOF enabled. Spring Boot cache integration. Product cache. Category cache. Session cache concept. TTL strategy. Cache eviction. Redis monitoring commands. Production checklist. Docker Compose. Services. Redis. Image Redis latest. Container name. E-commerce Redis. Ports. 6379. Command. Redis server. Depend only yes. Require pass, $, Redis password. Volumes. Redis data/data. Volumes. Redis data. Spring Boot config. Spring data Redis. Host, localhost, port 6379. Password, Redis password. Cache keys. Product, 1001. Category list. User session ABC123. Rate limit, user 501. Final summary. Redis deployment is an important skill for backend, full stack, and cloud-native developers. Important concepts include local Redis, Docker Redis, Docker Compose, Redis config, Redis authentication, persistence, RDB, AOF, max memory, eviction policy, TTL, Spring Boot integration, replication, Sentinel, cluster, Kubernetes, monitoring, backup, production checklist. Key idea. Redis is simple to start, but production Redis requires security, memory limits, persistence decisions, monitoring, and high availability planning.